With that, I think we'll go ahead and get started. First off, I just want to thank our Tech Talk series sponsor, Bosch, who's our host today, and also Argo AI. We've had a really great series so far, and we hope you're excited about everything that's going on in tech in Pittsburgh. And so with that, I am going to turn it over to Chris Martin, who is the Director of R&D for Bosch, to tell us a little bit about what's happening in Pittsburgh. Thanks, Chris.
Thanks, Allison. It's a pleasure to host all of you virtually wherever you are, whether you're here already in Pittsburgh or far afield across many time zones, as I know many of you are. Thank you for your interest. Thank you for joining us. I'll just say a couple of words and then I'll pass it over to more interesting people on the call, frankly, Sam and Sekar, who will tell you a little bit more about what we're doing in Pittsburgh. Yeah, I think it's pretty exciting and also by a nice coincidence, pretty amazing. As Allison mentioned, the two sponsors of this talk, Bosch and our colleagues right down the street, Argo, we're in a part of Pittsburgh called, previously called in general called the Strip District, but also now called Robotics Row. And we're two leading tech companies, like literally, it's not just Robotics Row, it's Robotics Block, right next door to each other. And I think that this is sort of indicative of the critical mass that is now in many of these, whether it's areas that we're working in, whether in technology or in finance and healthcare, and which I hope everybody on the phone call can use to find their opportunity to be find their place here in Pittsburgh. We're a little bit of a old school resident here of Pittsburgh. I'm not originally from here myself. I came almost 25 years ago to go to school, and also Sekar and Sam on the call here. They also have their own connections to Carnegie Mellon. But Bosch is more than 20 years here as well. So we launched in 1999. And we're here because of the ecosystem, because of the environment, because of the community that's here, especially because of Carnegie Mellon, but also extending our outreach. And today's talk is really about that. It's a Bosch story, and there's lots of amazing individual contributions, again, from Sam and Sekar. I'll tell you their stories. But it's also a Pittsburgh story because it started off from a collaboration with a local startup, Astrobee, which itself was a spinoff out of CMU. And through the unique strengths of our respective organizations, we're able to not quite get to the moon yet, but we're up in space at the International Space Station. And that came because our friends on the other side of the street, on Smallman Street in the district, Astrobee, and now they've moved to the north side, we were literally running across the street working on co-development of the SoundSee payload, which is our audio AI technology to diagnose the International Space Station and to keep our astronauts from around the world up there safe. So again, it's a Bosch story, but it's a Pittsburgh story, it's a Carnegie Mellon story, it's a regional story. And we're really excited to have the chance to tell you about how we got there and what's to come. I think with that, Sam, I'll pass it over to you and you can tell the most exciting parts of that story.
Sure, thank you, Chris. Yeah, really looking forward to talk more about that. So let me share my screen here. Please let me know if you're able to see my screen and hear me okay. All right, great. So thank you, Chris, again. And I'm so excited to talk about SoundSee, Bosch's first space mission to the International Space Station. So what is SoundSee? SoundSee is many things. From a technical perspective, I would say SoundSee is about, this device that you see over here that we built with a lot of microphones inside that moves around the space station, monitoring the sound of all these complex things, equipments and machines on board the space station. And that device works together with this really cool robot that NASA has built and launched. We're going to talk more about that. But SoundSee is also, as Chris mentioned, is also about team effort. SoundSee is about the intellectual freedom in a research lab like ours, that meaning when you have the right kind of organizational support and a passionate team, how can you go from an idea, literally sketches on a paper, to launching something to space, real footage, by the way, from our launch, in a matter of 2 years. So that's remarkable. I never imagined this is possible personally, right? So always love space stuff, but then this is what happened, right? And again, this is also possible because, as Chris mentioned, also because of the awesome city of Pittsburgh that we live in, without which this kind of collaboration partnership, for example, with Astrobee, which was instrumental for us to execute this space mission, would never be possible. And thanks to, of course, our partnership with NASA. So we feel really fortunate to be able to do this, right? And you're going to hear a little bit more about our journey. It's still ongoing. So we are actually operating in orbit pretty soon. It's already in space. But before I say anything further, I would like to have you guys, hear about SoundSee from someone who, let's put it this way, knows the use case in space a little bit better than me or anybody out there. Someone who spent more than a year of his life in space, Dr. Mike Fole. He former astronaut, 6-time spaceflight veteran, and former commander of the space station. Okay, that's not good. So the video might be a little choppy, but I thought it will be still worth playing. So here goes.
I spent over 370 days of my life in space. The day I had my first spacewalk from the space shuttle, I was very excited. I saw the Earth, and the galaxy was breathtaking. Space is a fascinating place, but it's also a place where failures can lead to serious problems. As a former ISS commander of Expedition 8, I know the schedule can be really tight for the crew, doing exercise, experiments, and maintenance. That's why I helped develop Bosch SoundSee. It's designed to identify imminent failures by analyzing machine noise. So with the help of artificial intelligence, we can hear when something's about to go wrong. I'm convinced the interaction between humans and robots will help humankind move on, not only in space, but also on Earth.
So I hope we can get the spirit of SoundSee, what it's meant to do, and where we're going to see it go in the future, right? And we are so incredibly fortunate to be able to work directly with astronaut Mike Fole, who used to be the commander, as I mentioned, for this mission. So that aside, let's now look at, so the video aside, now let's look at what we are actually doing, right? So the story of SoundSee starts with this really cool robot, right? A robot like no other, right? It's called Astrobee that NASA built. It's an experimental robot that can float around in 0G in the space station. And SoundSee happens to be the first ever commercial payload on this robot, right? It sits right over here, as you can see. And Astrobee robot has this autonomous mobility capability within the space station. It's been mapped. It uses visual SLAM capability to navigate around obstacles. And SoundSee actually writes on it to do interesting things and execute its mission objective. So what are those? Let's look at them. So this robot was actually launched last year as well. So as you can see from, this is one of the modules inside the ISS. This is the US lab module. So all these complex machines and equipments generating a lot of noise, and each noise has its own meaning, if you will, right? So what do we do there, right? The first primary objective of SoundSee is to use the sensitive array of microphones that we have inside SoundSee to capture this audio emanating from all these equipments and machines, and then use audio AI to be able to analyze them and spot potential anomalies from those audio signatures. So in a way, SoundSee plus Astrobee combination is supposed to be the meticulous, tireless listener, which goes around the space station, always looking for those situations when you and I probably will go like, that doesn't sound right. So how do you do that actually with AI? So of course, we are not going to talk about the algorithms and stuff, but in essence, the core capability is that, to be able to spot anomalies from the noise signature. So, and why do you want to do that? So one of the equipments that you want to monitor is this 3 equipments over here you see. It's called ECLSS, or Environmental Control and Life Support System. Very important because it produces oxygen and recycles water. It's a very complex electromechanical system, and maintaining it is very important. A lot of time, as you mentioned, as you saw Commander Fole mentioned, a lot of time is spent on maintaining them, right? So always NASA and the space community is looking for novel ways to monitor their operating state. And this is where SoundSee comes in, to hear the sounds and look at, spot potential degradation of performance potentially, right? So that's where audio AI will help understand the health of machines. But also another interesting thing which can relate to even autonomous driving in a way, which I'll come to soon, is that using the trajectory of the robot, as you see, Astrobee is not possible here on Earth, unfortunately, because of gravity. But as you float around together with SoundSee, we could, using the microphone array without going into too much technical detail, what we can do is an image of all these sound signature coming from this different equipment, sort of like this heat map, as you can see. That's why the name SoundSee, seeing with sound, if you will, right? And to understand how the acoustic patterns are changing and where it is coming from to create this visualization, you can tell the reason why I'm saying autonomous driving. Imagine how the lidar on top of an autonomous vehicle rotates mechanically, creating this point clouds. Imagine doing the same thing only in audible space using SoundSee. So that's pretty interesting and exciting novel research that we want to pursue in the space station. And we don't just want to go to space station and do this experiment, but they have to have applications here on the ground. And that's why you got funded to launch to space, actually, right? So you can imagine similar technologies with mobile robot going around any infrastructure, with complex machineries, manufacturing floor, going around checking the health of these critical equipments, which leads to economic value. So that's obviously is very important for us, for NASA, to see how space infrastructure like space station is being used to generate value proposition for here on Earth. So in order to build SoundSee, right, we had to set up an environment where you could develop this payload that we did, right? How do you really optimize the number of microphones you put there? What geometry of the array to use? So we did all of that by our first iteration of SoundSee ISS simulation facility, where you use a ground robot. Sorry, we cannot use flying robot in this case, of course, because of gravity here, but it's omnidirectional robot. You put SoundSee on top of it, and it did all this acoustic experiment. This is a picture from Astrobotics High Bay, when back in the time when they were in Spirit District. And now more recently, as we develop the payload, now we have upgraded to a much more advanced facility here in Bosch Research Pittsburgh. As you can see, we are kind of mimicking the inside of the space station here with this robot that Sekar is going to shortly talk more about, and continue doing our experiment as we, of course, carry on this research. But building this proof of concept and everything is good. We do that all the time for our terrestrial activities. But what we learned from this experience is that it's one thing to build a proof of concept that works here, and the journey from there to the launch pad is a very long journey, right? And we never worked on space mission before, and that's what I want to share as an engineer, as a scientist. This is really exciting to learn all the different deltas you have to come through, right? To have a payload, electronics working here, to really meeting all the flight certification requirements, right? It's a team effort, right? So we had to go through all these different stages of NASA's, space mission milestones. For example, this is a picture from our preliminary design review, or PDR, and then you have a CDR, or a critical design review, right? We did together with Astrobotic, right? As you can see, astronaut Mike Fall right in the center. So we did many of those to really mature our design. And then finally, last summer, we had to do a lot of tests, and this was a learning experience. A lot of nail biters and really, test situations where you have to make sure that everything works. So this is one of the pictures, as you can see here. This is from the NASA Ames Research Center in California, who built the Astrobee robot. So we put our orange color SoundSee over there to make sure the integration test works. We had 3 different tests for EMI, electromagnetic interference tests at NASA's Johnson Space Center. Of course, after a lot of iterations, we had to meet the requirements, right? So that's what I'm saying. It's all fun and exciting, but when it comes to bare bones, to make sure that everything works, because it involves human spaceflight. It's not some CubeSat that will go around the Earth with nobody's going to touch it. When astronauts are involved, the bar is just too high. So that was an amazing learning experience for us. So, and I would like to always point out that this is a team effort. So many interns, individual full-time associates, everybody contributed a little bit by bit on this to actually make it our journey to our dream destination, which is on top of that 139-foot tall Antares rocket on November 2nd of 2019. And like I said, we have seen many rocket launch before, but this is special because it has something we built on top of it. And again, I couldn't thank enough to our Bosch leadership as well as Astrobotic leadership to trust us to, take this journey with us. And then we reached space, right? And so we were really excited when that happened. And then of course, on November 4th, we arrived at the space station on this beautiful Cygna spacecraft, which was our vehicle to the space station. So that's pretty exciting that we have been able to reach space station, like I said, from a sketch on a paper in Bosch Pittsburgh to this moment in matter of 2 years. And what is happening now, right? As of beginning of this year, astronauts did unpack SoundSee, as you can see, is floating in 0G, so it's all real. And right now, we are actually working. So you have to work with NASA to schedule this experiment with the astronaut, because astronaut times are very critical. So we have daily, weekly, meeting, sometimes daily, sometimes weekly update meeting with NASA to really finalize the procedures, right? So as I'll show you, we do have a mission control, right? In order to execute this operation, you need a mission control. So we have one of the mission controls for space station operation right here in Pittsburgh in our office. And so we have to finalize a ground procedure, I mean, what we have to do as we carry out the experiment here on the ground. And then NASA, we are working together to finalize the exact steps that the astronaut has to perform there to work with SoundSee together with the Astrobee robot. So this is in the final process. And hopefully by end of this summer, by end of August, we'll have our first experiment carried out in orbit where we'll be in the voice loop to give guidance and do this. So all of this is almost like a dream, to be honest, right? To be able to do this right here in Pittsburgh, working together with Astrobotic, this has been a fascinating journey. So that's going to happen. But in parallel, we are, of course, getting at our research, right? There's two aspects of it, as I mentioned, right? Using sound to see things, right? So we have this, this experimental setup, which Shekhar will talk about. We are carrying on with the simulation experiment, algorithm development for that sound seeing, if you will. In parallel, one of our core competency, as I mentioned at the beginning, is to use subtle cues in the audio pattern to understand physics of things, or physics of machines operating, physics of events happening in the environment. So this is where, of course, we are also a fan of deep learning, I would say, like many others. And of course, there's a lot of value to be added with deep learning to understand audio, to spot anomalies of machine operation. So that is also happening in parallel. We have a lot of exciting new results there. Of course, we do not have the time to cover there, but with that, I'll also let Shekhar, who is a PhD student in CMU and also a research intern from the SoundSee project, who helped us set up some of the experiments that we are carrying out or will be carrying. So that will be something really interesting for you guys to hear about and have a much more first-hand experience from someone who worked on this project from an intern's perspective. So Shekhar, please take it away.
All right, let me share my screen. All right, is it up? Okay. So my name is Shekhar Kalundiville. I am a current research intern with Bosch, and I'm currently on my third internship with Bosch. I've done 2 summers and a part-time school year. So the part-time school year was the work I did with Sam, and hopefully today I'll tell you guys about our project and how that's and how that relates to the overall SoundSee goal. So this is a look at our SoundSee lab. Our goal in launching SoundSee, so even though we're launching SoundSee, we also need to practice for a target environment, right? This target environment could be either in space on the ISS or in a warehouse listening for different sounds like glass breaks. There are different sounds going on with the machines in a warehouse. But of course, in order to get to this goal, we need 2 different things. First, we need our own experimental setup for both testing and verifying that SoundSee works on the ground. And then we can also have our own replica of the Astrobee robot, right? So when we have our payload on the space station, we want to be able to, when we do experiments on the space station, we want to be able to take that data and replicate it in our own ground-based lab. So here is the SoundSee lab. We call it our ground control. You can see in the back that there are 2 computers. On the left is for our testing purposes, and on the right is eventually where NASA would install any software for communicating with the Astrobee. Now, to run all of our experiments, on the left, we have a quiet room where we can shut the door and make sure that all of our audio is, we can control all aspects of the audio in our experiment. So now let's take a look at what goes on inside of the quiet room. So as we step into the quiet room, this is what we see. We have a few, we have these panels that represent basically the ISS, and we also have some speakers that can represent interesting sources of noise. So imagine on these speakers, we could play some noise from the life support system, or we could play noises of like glass break or of different machines going wrong or going bad, like motors malfunctioning. And ultimately, we have in this room a robot that will act as our replica Astrobee. We want this robot to kind of simulate or mimic how Astrobee moves around in our quiet room so that we can do our testing. Of course, you know, we have gravity to deal with. So this is our version of a floating robot. We put it on a mount. It's a few feet off the ground, and we put it on a robot that can move omnidirectionally. So it has these wheels that can go left and right. It can the robot can move to the left. It can go forward, spin around on a dime. And on the right, we'll see a close-up of the Bosch payload that we can mount on top of this robot. And in the center of the Bosch payload, you'll see these LEDs, and in the very center, and in between that is the array of microphones that will detect all of this audio information from its surroundings. So all of these microphones, they provide the audio data, and we'll eventually see how what SoundSee actually sees from the view of the robot. So unfortunately, the robot doesn't have any sensors to let us know exactly where it is in the quiet room. Where the Astrobee robot has a SLAM system, it knows exactly where it is inside the ISS. We have to create our own setup using a motion capture system. So here we have this these motion capture cameras that basically track the robot's precise location. And in order to get this setup to work, I had to learn ROS, or Robot Operating System, and we could combine the information of these motion capture cameras that would basically track where the robot moves in the room, and we would use that feedback along with the controls to the robot. And by integrating these two things together, we could now put together a full ROS stack of a robot that can use sensor information from these cameras, and we can also do some kind of path planning. So we can tell the robot, go to this position, and the robot will go there all by itself. And this is going to be this will be very critical for our experiments. We can say, hey, there is a noise source coming from this corner of the room. Can we have the robot go to that corner and maybe do a sweep around to figure out exactly where that noise is coming from and what that noise is? So here's an example video of the robot moving around in the quiet room. It moves autonomously using ROS, and it allows us to have like a very fundamental experiment control so that we can do all of our testing for SoundSee. Now, of course, now that we've accomplished having this robot move throughout the room, let's actually take a view from SoundSee, or from the SoundSee payload as it sees interesting sources of noise inside our quiet room. So you'll see here, this is basically the view from the SoundSee robot. The robot will sense these hot spots of noise. And of course, you can see that these hot spots of noise are coming from these speakers. And another example is, let's say we turn speakers on and off. You can actually see these hot spots turn on and turn off. And this is just the raw information coming in. This is the raw information as a visual coming into the SoundSee system. And eventually, this information will go into the SoundSee algorithms, where they can learn and train to figure out what exactly that noise is producing. Where is that noise producing? And now with the ability to control where the robot is moving in the room, we can now say, hey, this is the best path for us to scan this source of noise, and maybe we can figure out exactly what's causing this this source of audio. And of course, now that we also have an experimental setup, now that we can get stream, or eventually we'd like to get streaming data from the Astrobee, and that will give us the most realistic feedback to make SoundSee better and more accurate in terms of its operation. Yeah. Yep. Thank you.
Thanks so much for both of you. And Sam, and Sekar, I don't want to jump in if you're still going, but I know there's a couple questions that have come in, and I have a couple questions if it's time for that.
Sure.
Well, so first of all, I just chatted Chris and said, you know, your day job is not like my day job. This is amazing. And for me anyway, so outside of what I normally do, but it's really incredible to see. I wondered if you could talk a little bit. I actually had the pleasure of checking out some of your new technology for an online platform. And it was on a session where I think it was physics, but what was on screen was just unbelievably complicated math that you all were going over together. So can you talk a little bit about kind of the skills you need to work on this type of technology and how you're working in teams and things like that, particularly for students who are interested in going into this field? And, you know, it's kind of outside the box for a lot of people from school and everyday life, that it'd be helpful to have a little bit more context for that.
Sure, I'll be happy to talk about that. And the good thing is that the kind of work that we do, at least this particular space mission, it has roles and expertise requirement for various backgrounds. It's not just one thing fits all, right? So for example, we think about the core algorithm, right? For those, we need someone who understands signal processing, right? Electrical engineering background people, and machine learning, computer science, electrical engineering background, those kind of things. But also, this is, I'm specifically just talking about the algorithm piece. When you talk about physical hardware, right? The electronics that will collect the data and basically to understand how the robot would move, then you also go to the bare bones understanding of how to design hardwares that works robustly, right? So hardware design expertise, understanding of robotics, how robots navigate in the space. So all these different capabilities that make a robot work. For example, you know, computer vision, simultaneous localization capabilities, all those core robotic, core competencies also are important for this project. Of course, we are not directly working together with NASA for those specific robotic capability. Our focus has mostly been on signal processing and machine learning and AI topics. But in principle, if someone has expertise like those, they can also contribute to the project. Is my very, I would say, on a very technical level is what I'm talking about here. But it's also very important that this kind of project is not so much about technical contribution, but also to understand people working on different technical topics and understand each other, right? So we are working with 2 different NASA centers. We are working with, companies with different kinds of background, right? So for example, Astrobee has space robotics expertise. They understand how to get space flight certification. We, on the other hand, have never worked on space applications before. So we work more on the ground applications to understand this, how do you work with people from different backgrounds, how to, work together towards a, broader goal is very important. So teamwork is very, very important in a project like this when you have multiple organizations involved together. So this will be my perspective here.
And let me just amplify everything that Sam said, and to, at the risk of blowing up Sekar's ego a little bit too, is, right, I mean, he represents a very special kind of contributor that we're lucky to have on an activity like this. As he mentioned, right, this is he's currently pursuing his 3rd internship together with us, and that's in something we haven't even really touched upon now within our security and privacy research group. But I think all of the things that Sam mentioned, plus a little bit, even though we live in a digital world, it's important to remember all those, call it analog skills. I'm not talking about like analog circuits. I'm talking about the sort of the quote unquote real world, right? Working in the lab, getting the proverbial hands dirty, building stuff. Bosch at its core is we're a thing company, right? We talk about the Internet of Things or the AI powered Internet of Things, and we make stuff. Some of which some of you maybe have touched, either our power tools or our appliances or almost every vehicle on the car today. or on the road today has a Bosch product. And Secker has told me stories about going to junkyards and picking out ECUs from cars and hacking things down in the CMU garages and all that kind of stuff. If I can offer any advice, is as I was I actually started my career as a Bosch intern. I had done a couple of other internships, and this is, I think, a great time to go and kind of don't always run deep within your internships. Is don't be afraid a little bit to go a little bit broad with this to find not just from a skill development, but from also your own personal development. What do you like doing? What do you find natural? What comes easy to you? And I think that with Secker working in so many different ways, in so many different teams, and contributing in ways that we didn't even really anticipate.
Yes.
Which were there when we first started the conversation with them. I think that's also shows the depth and breadth of the needs on a project like this, just like Sam has mentioned.
Indeed.
And Secker, can you talk a little bit about Pittsburgh? I think Carnegie Mellon brought you here, but what's it like to be in Pittsburgh? Where are you from originally?
Sure. Yeah. So I'm in my 5th year here. And I'm originally from Silver Spring, Maryland, so like right outside the DC area. And I'm currently living Shadyside. I've like lived everywhere, like from Crafton near Robinson, and like Shadyside. And I travel around a lot in Pittsburgh. And honestly, I have to say I've had a very good time in Pittsburgh. There's a lot of like fun activities, especially the events last year at Passport, kayaking, all of the tastings and all the different events. Those were very fun. I'm kind of glad that Passport was there to provide us extra events. And I think Pittsburgh is definitely a big up and coming area. You're starting to see lots of different companies, and the appeal for tech internships and or tech related internships and even just internships in general is starting to grow. You can see it, just drive around and you'll see new companies popping up. I'm really, for myself, I'm very glad that I did find Bosch, and clearly I'm on my 3rd internship. So I definitely do plan to stick around. So yeah, Pittsburgh is definitely a top place for me.
Awesome. Thank you for being a Pittsburgh ambassador. We need as many as we can get. Ranjit, you had a question, you raised your hand. And Gia, nice to see you here from Cornell. Okay, Ranjit's going to ask his question here. Sam, how about you? You're not from Pittsburgh either. Kind of, what's your take on Pittsburgh and how long have you been here? Where are you from?
I'm originally from India. Came to the United States 14 years back. Been in Pittsburgh for the last 10 years. And, I came as a postdoc and research scientist at the Robotics Institute at Carnegie Mellon. And I, decided to, not leave Pittsburgh because I really loved, again, like the technology and collaboration spirit in the city. And then even being part of a corporate research lab that Bosch is, I always say this, we are lucky to be in a quasi-academic kind of a setup where we really can pursue our passion for basic research, but at the same time also make practical impact. So again, this is my very narrow angle of where Pittsburgh really excels, right? It has this amazing collaboration spirit about companies and the universities that we have here. So this is what has been, for me, is a dream come true. So I've been here like 10 years now and don't leaving anytime soon.
And Sam, I already blew up Secker's ego, so now it's Sam's time. And Allison, your question is really well placed because we're lucky. And Sam we came to Pittsburgh back in a time when it wasn't quite automatic to come here, right? Like 10 years ago, we weren't winning. We weren't like the 2nd most livable city in America, just behind Honolulu, Hawaii, which shouldn't even count. Right? Like, we weren't featured as like the #1 city to eat in, Bon Appetit magazine or something like that. Right. We didn't have sort of these accolades that are being bestowed upon us now. And so, I think that now, especially now that we've moved through that time and we are being recognized and we do see this, this investment, I very much appreciate, people then who took the leap to come here and now, right. If you look at our team, the depth, the breadth of regions from around the planet, that I am humbled to be able to work with people. You say, Allison, your day job isn't like my day job. My day job is only awesome because I genuinely can say that, we have the best people, some of the best people from literally around the world. Now some of them potentially going out of this world, getting a chance to work with. And, this is, I think, yeah, exactly, unintended. So this is really what, and this comes from the connection to the university. So again, people like Sekar that come to Pittsburgh from CMU, people like Sam who come to CMU not as in a postdoc role, and then take that leap to do that. So, I'm hoping that we can build on this legacy because it's been a 2-decade journey for us here, and it's exciting to see, now that we have hopefully a critical mass. And I'll just talk about the tech sector. Of course, there's much beyond that, but I'm hoping that we can build on this as just being an absolute top tier destination, a welcoming community, an exciting community that people say, hey, I'm gonna go there, and there's everybody. I could go to the Valley, which is, I spent time in the Valley, and I did my time there, but it kind of feels like I did my time there. But this was a choice, and I hope that this is also people are excited when they say, hey, I'm coming here on purpose. I'm coming here because it's exciting. I'm coming here because it's one of the most livable cities on the planet.
I think we got our soundbite. So Ranjit, I wanted to ask your question. He said, you mentioned that the launch happened in November on the 2nd, so it's been about 8 months and you've had some time to reflect upon the mission. What have been the major challenges you didn't expect during the simulation or testing phase? And then Everardo, we'll get to you after that.
Sure. No, that's a very great questions, right? So 2 tracks are happening in parallel. So one is, of course, the on-orbit operations that are going to happen in orbit. So for that, we are continuously making progress together with NASA to finalize the operations, both from the ground and from the crews or astronauts perspective, and that has many steps, right? So each and every experimental setup, the outcomes needs to be articulated, and that's what has been done. It's more of a process-oriented stuff right now, right? Science will only happen when we actually get to the experiment. That's happening hopefully by end of August. But in parallel, we are already working, as Sekar was mentioning, working on the experiments and the simulation setup. One thing I would like to answer more on technical term is that what we're trying to do with a mobile robot, which is location aware, and putting a microphone array on top, this is not been done before, to the best of my knowledge. Meaning what we are trying to do is that, some of you might be familiar with how satellites that go around Earth does imaging. What it does is that it aggregates images along its trajectory to create a high resolution map. But we're talking in this case of optical domain, right? Actually, it's things you can see. When you're talking about audible sound, which is a long wavelength and everything, without going into too much detail, there's a lot of challenges when you're trying to do imaging in the audible sound domain, right? So what we're doing, we're building novel techniques, what we call synthetic aperture acoustic imaging, meaning you aggregate your audio information from multiple sources, multiple locations, and you are already aware of the locations to combine them to create a synthetic virtual array, which is like a long cylinder, if you will, right? Nobody will take a microphone array like Amazon Echo, for example, and walk around the room to do better imaging. But because of the nice setup we have with the robot autonomously moving, and which is location aware, we're able to do this really unique experiment. Is it easy? Of course not, right? So we have now really interesting results of state-of-the-art signal processing technique together with machine learning to show that when you have static, well-behaved, let's say, acoustic sources, we can actually do this imaging. So it is the brand new result that we have. And we're so looking forward to actually feed that algorithm with our data from orbit to actually do the mapping of the ISS, right? In parallel, of course, we're doing many other things with AI, but this is something I would like to highlight, that this is very challenging. It has never been done before on a mobile robot going around with the array. And it is particularly challenging because the audio sources are very close to the array also, because ISS is not very big, it's a couple of feet here and there. So those poses challenges, but so far the results we have gotten with the kind of simulation we have, we are pretty excited to really try them on the real orbit data. So this will be more on the technical side, the challenges and how we are addressing it. But of course, we are also looking for the additional challenges that the unstructured environment on the ISS, which is not so well behaved, maybe with our simulation setup, will throw at us, but that's the mission is about, and we're going to explore those.
I think also, as Sam mentioned, right, so many things that we didn't anticipate. Also, Sam, I don't think that you mentioned this, right? The crew that's carrying out the test, to actually exercise SoundSee, they were the crew that was launched on the SpaceX rocket back in May, right? So Sam and I separately, like watching the SpaceX launch, and this milestone for commercial and U.S. spaceflight and international spaceflight, of course, and just having that little extra investment, right? When you see the rocket go up, and and of course you're rooting for humanity, right? But there's a little selfish part of you that's rooting for us, right? Those are the gentlemen that'll be doing the tests, as part of it. So Sam showed the rocket launch back in November of the rocket, but then we saw the one in May, and there just continues to be this steady stream of just unreal moments, right? Hey, let's just go have dinner with the guy who lived on the space station for a year and have him tell us stories about how Mir almost crashed, right? This kind of this intersection of the emotional and technical. This is something I certainly had no anticipation whatsoever that this would be part of our daily job.
It's been very rewarding, to say the least. And to echo what Chris just mentioned, it's been 8 months, and of course we are trying to schedule experiment. Part of our expediting our experiment was a SpaceX launch, because before the SpaceX launch there was just one US astronaut on orbit, because of course the SpaceX was doing more tests. But of course now we have 3 astronauts, and there'll be more astronauts hopefully with more SpaceX launch. So more experiments, the more astronauts, the more experiments could be carried out efficiently, as you can imagine, right? There is many people, the same spacecraft that took SoundSee, there was the most important payload that also was carried with our payload was dark energy detector from a physics professor in Cornell or somewhere else, I don't remember. So that's a pretty exciting, company to go to space. So all these experiments from different universities and institutions do get carried out one by one by the astronaut, thanks to them. But also you have to make sure that the ISS is tough enough and running efficiently to make sure we are on schedule at the right time. So that's all been excited. And like I say, no matter when the experiments happen, we're all super excited to be part of it, to be honest.
Ever, do you want to jump on and ask your question?
Yeah, hey, I'm a bit curious to hear more about what your development process was like. So, did this start as a research project involving machine learning to see if you could, classify audio, or did it start with the robot and then, oh, we want to solve this problem, how do we solve it, what do we throw at it, what came first?
We knew everything how it was going to go right from the very beginning. Absolutely.
So that's the previous one, right? So we have been working on, this has been a long journey. SoundSee didn't start with the space missions. SoundSee was more about our passion for space and then repurposing some of our audio AI research into the space project and the robot that NASA has built, right? So long before that, several years before even the mission started, I would say early 2018, fall of 2017, we've been working on audio pattern classification. As you all know, that the most obvious thing people say AI and audio, you'll think about speech recognition, right? And people have, very respected people. It started in the 70s in CMU actually to analyze audio from humans, it's a speech, to understand things. But a lot of more research to be done when you try to understand the other unstructured sound signatures from the environment, right? Because that involves different types of physics as compared to how audio is generated by human vocal tract, right? So you have to learn representation for those audios and see if you're applying it for understanding machine operation, or you are trying to understand different audio patterns, something that you want to figure out where the glass break happened or gunshot happened or whatever, right? So these are the core fundamental research problems that we've been working on. So for quite some time, for business application, for research application, we do publish a lot. We have patents that we have got granted. And then of course, space station operations was more like, yeah, there's an opportunity with this robot that we could really utilize in a very novel setup, as I explained, right? There's no other robot that floats around and you can put a microphone area on top of it to do this synthetic aperture business. And yeah, it's the first time it'll be done. So that's how it came to be. And of course, it also augmented our research capability. It didn't start it that way. So that's, to answer your question, yeah, that's how it all gotten to where it is.
And I think that's a good segue into Linda's question. About, why are we doing this, right? So, there's only one space station, right? So that's not a huge total addressable market there. What Sam mentioned is he is also, pretty much within Bosch, he is well, he's pretty young to be a godfather, but he is the godfather of audio AI research in this area, right? One of our collaboration partners at CMU, talks about, the work that we're doing, is all of the information that is in sound that is not speech, and that's tons of stuff, right? That's really what we do. And so, I think that this is, Linda's saying, well, what are we doing with this? And Sam already touched upon it a little bit, and Sekar as well, is right. All of us know, maybe a friend or a relative or somebody you work with, and it's like, oh, my car is not working. Oh, well, what sound's it making? Is it rattling? Is it humming? Is there something coming from my dishwasher or refrigerator? Of course, it wouldn't. If it's a Bosch refrigerator, it'll run forever. And so, but there's clearly information in there that we as humans can process. We don't necessarily, and you ask this person, how do you know this? How do you know it's the carburetor? Or how do you know it's the heat pump or something like that? And they'll say, I don't know, I just know because I've seen it. It happened in the past. And so now this is one of those things where if you can, the hypothesis around AI is that if you can teach a human to do it, or if a human can do it, right, you can teach a computer to do it. And this is really what we're talking about. So all those Linda, what you mentioned here about, commercial or residential repair, what Sam showed in his presentation, right, is we don't have 0G on Earth, which is, good for us humans. But we can, so we don't have robots floating around, but we can have robots driving around, right? You referenced a Roomba, right? Have industrial Roombas, right? Right now we have, whether it's security guards or regular maintenance technicians that just walk around a factory, but they really, it's very difficult to really pick up on perhaps imperceptible or barely perceptible, or even things outside the human hearing range that we might be able to use. So industrial applications, mobile applications. So for example, teaching autonomous vehicles to hear sirens where maybe they could not see them is another thing. So there's really, Sam's godfatherness allows him to have a litany of use cases beyond which I can only dream. But that was where it was really born out of that. And we're hoping that through the breadth of our portfolio, again, Bosch being an IoT company with a big T with these things, that we can augment our things with these capabilities across our entire portfolio.
So we probably have time for maybe one or two more questions. I have another one, and if anybody else has any, please feel free to put them in the chat. But you launched this. Have there been any examples of problems that you've solved so far since it's been up there, or right now it's just compiling data and moving toward the future? Has there been a problem solved because of SoundSee yet?
Not yet, but there's fingers crossed. We're hoping to do that. But the experiment is going to start, like I said, end of summer, where we're going to acquire the actual data from the ISS. Because one thing that I'd like to add, maybe I didn't cover, is that SoundSee doesn't work by itself. SoundSee sits on the robot, and it gets power from the robot, and all the data that it collects from space station goes via the robot that NASA has built to us here on the ground. So right now, the robot testing, like I said, also, the robot is also brand new. That NASA is also an experimental robot that NASA sent, and they are commissioning activity, meaning checking to make sure that the robots are functioning as expected, is almost complete. So we'll be right after that to integrate with the robot and collect this data. And hopefully, as you mentioned, Ellison, we'll be finding something interesting. That will be nice.
Yeah. And let me also tell you a story that was shared with us by our astronaut friend and supporter, Dr. Full. The way that this is, modern innovation is kind of a little bit, at least in a corporate environment, is a little bit different than it used to be. And what do I mean by that? It's sort of not just, PhDs and super smart people like Sam and Sekar sitting around thinking smart stuff up. We're much more challenged to say, okay, listen, if we have this idea, whose problem will it solve? Right? Like not from a, how are we making the world better, but, are you saving time or money or energy to the environment? And, Sam can tell the really details of the story, but this is something, the reason why Dr. Full is our champion in this is because it solves his problem. And what is his problem? And as Sam mentioned, astronaut time is really expensive. If you want to go book an astronaut to go do your experiment in space, you can go do that. Like you can say, I want my astronaut to grow some plants or whatever, I don't know. It will cost you $55,000 an hour to book that astronaut. However, the astronauts they're not 24 hours free, right? They have very rigorous schedules, regimens, all this kind of stuff. So they have a really limited amount of time to carry out this productive tasks. And this, a bunch of time is spent maintaining the space station or the space shuttle or whatever. And so what we heard from Dr. Foll is that once every, I don't remember if it's once every 10 days or once every 2 weeks, what the astronauts do in the space station is they literally float around with a pencil and paper and a decibel meter and point it at things and say, okay, that's 60 decibels or that's 80 decibels or whatever. The reason is because the space station is actually considered by the United States to be one of our national labs, and it's subject to OSHA requirements around sound safety, right? So just like a factory or a lab, it cannot exceed a certain volume, or else there's potential hearing or brain damage in this, right? So the astronauts literally float around the modules and say, okay, it's not taking this right. So it's very low coarse grain, whatever. So what Dr. Foll and the other astronauts say is like, listen, save me that time. He's literally got, Sam, I don't know what, the PhD in physics, and he's like literally one of the most highly trained humans on the planet. They see themselves and they want to maximize their value, their productivity. We are solving their problem with this. He's on board because he doesn't want to float around, he or his colleagues don't want to float around taking down relatively stupid notes. This is a good example of solving a problem of, now in that case, it's a very expensive problem, of rote analysis and data collection that a highly trained human has better use of their time. But we've heard the same thing. We did similar work together with the facility management service at Carnegie Mellon, and they said the same thing. Is they don't want they are highly trained professionals. They're excited about automation because they see that this is something that removes the low value portion of their job. The number of things that they've got to do is it's a million things they got to do on a given day. Get rid of the low value stuff such that I can get at the high value stuff, and that's where we see a huge potential around this. And I think that really speaks to really, what are our innovations doing? It's solving somebody's problem.
So I think for the last question, I'll just ask, and I know you all don't have a formal HR function in Pittsburgh, but if somebody's interested in an internship at Bosch, I know you guys have a pretty robust internship program. Any full-time opportunities that come up, where would they find that? How do they get connected to you all?
So I'll answer that one. So we have on our main webpage, we have links to all of our internships and our full-time opportunities. Regrettably, just because of coronavirus, our internship program this year is probably about a little bit less than half than it was last year. But we normally, I think we had planned to be, 40, 50 strong here. And Allison and I will take this opportunity to do what you asked me to do, and then I forgot, which is to say that's the Bosch office in Pittsburgh where we normally be, and that's about where Sekar was hanging out in the lab, right over about there. The Allegheny River is about right over there. Downtown is down there. So normally would have a much more robust internship program. We have both within our core corporate research, and as well as I'll do my other branding. It's reverse, but the Bosch Center for AI, our new partnership with Carnegie, well, not new, 2 years ago now, Bosch Center for AI. I'm not sure how many full-time positions are posted at the moment, but again, some of this is just on pause as we all work through this current environment. But yeah, so you can find everything on I'll see if I can dig up the link real fast here on Talent Hub and different outlets. You can usually find the postings on LinkedIn too. I'll dig that out and make sure that we put the central list for everybody here.
Awesome. Well, with that, I want to wrap up so we're on time. Chris, Sam, Sekar, excuse me. Thank you guys so much for your time and for taking us through this. I do want to promote a couple of upcoming events that we have. So this Thursday, the Tech Talk series continues with Pittsburgh Technology Council. They are talking with tech hire from Duolingo, Highmark Health, and Dick's Sporting Goods, all who interned in Pittsburgh and moved into full-time roles. So kind of what it's like working in the technology space in Pittsburgh at a couple of different companies. You can ask questions about their career pathways and things like that. Next week, we have the sustainability of water with Evoqua, which is a water technology company that's headquartered in Pittsburgh, and really how they're kind of transforming clean water and sustainability efforts globally. and on July 21st with Ernst & Young, how to nurture your innovative mindset. So it's some information about what they're doing internally as a company, but also some tips about how you can really grow your skills and think outside the box and be more innovative in general. So you can register and get all the information for that at www.pittsburghpassport.com. Again, thank you to Bosch and Argo for sponsoring the Tech Talk series. If you have any questions, you can jump onto our LinkedIn group and ask them there. And otherwise, have a great rest of your week. Stay well, be kind, and we'll see you soon. Thanks so much, everyone.